Okay. So if you could remember whatever we have covered till last day session, the business intelligence first day, it was how we can build the meaningless data, that is transactional data from source system, and how we can transfer the same in meaningful data and store the same in data warehouse. The data warehouse can be a particular database, and that particular database should be storing the data, the meaningful data in either dimension or fact table. Okay. Those are the thing we have learned with some basic block charts as well. How that can be done? It can be done through an ETL tool. ETL tool means extract, transform, load. So how that, what is the strategy to load the data from source to target? That thing we'll be covering today only. First of all, I just want to take a quick look on fact and dimension again. Okay, so that thing we have covered in last session. Just a quick recap before we can start. So fact means, I mean, this is in data values, okay? So far we have created already the meaningful data. Over here, meaningful means the data on top of which data scientist can work, data analyst can work, the visualization team can work, okay? So that's the thing that is called meaningful data. It cannot be the same data from the source system. So that's the work from business intelligence or the data engineers. They are converting the data from source to the target with some meaningful data, and then meaningful data should be useful in nature. Okay. So within meaningful data, fact is the first thing. Fact is the data numerical in nature. So if we questions on top of data, how much, how many, so whatever answer we will be receiving, that numerics data or the measures data, that is called fact. Okay, let me repeat this thing once more time. Facts mean measure. If you are receiving this kind of information, revenue, cost, number of accounts, those are facts. And we are storing those facts information in fact table. Okay, so just like an example over here, sales and billing, those are the fact tables. And in the fact tables, we can see the red color highlighted things are facts in both of the table. And apart from that, we can find there are other columns available as well. Those are the key columns. Those are actually not fact. I mean, those are not measures. Rather, those are the foreign key to join with other dimension. So suppose we have dimension table called store table. We have dimension table storing product table. So those are the primary key from their table, and those have been used over here as foreign key, so that we can join between fact and dimension with these keys. So fact table does not consist with I mean with the facts only. It also consists with the foreign key of the different dimension. Okay, it's same as I mean it's same over here as well in billing table. There is date key, customer key, service line key, rate plan key. Those are foreign key from different dimension. I'll be showing you the later slides. From the diagrams, you can view the data modelings and all. From the diagram, it should be clear why we are using the foreign key. Okay. Yeah. What is dimension? If we questions who, what, when, where. So apart from these measures, whatever we can receive over there, those are dimensions. Okay. Let me show you. Yeah. Over here we have example store and product. In store table. Okay. This is store table. This is product table. So each of the table we can find there should be an unique key, that is the primary key of the table. Just like for store, store key is the primary key, and for product, product key is the primary key. So in the store table, we are storing, apart from the primary key, we have all store related dimensional information. What is the store name? What is the address of the store? The city, the state, region, country, same just like product. So what should be the product key, product ID? What is the product name, product group, brand, department? So those are the information for product dimension. Okay. Okay, so just a quick recap. So this store key or product key, those are the primary key in the dimension table, which we'll be using for joining purpose with fact table. In fact table, this kind of key should be there. It should be present over there as well as a foreign key, so that we can join between these two tables. So while fetching up the data, if you could remember, at the second class we already told you we are making this particular table such a way it should be normalized in nature. We are creating the table in normalized format and splitting different dimension for the same. We are splitting fact table for the same. So when required, we can join between these two tables and fetch the entire information. So that's why we are splitting several tables based on several subject areas. It should be either fact or it should be either dimension. Okay. Okay. Now related to fact table, we have couple of information. So while representing a fact table, we have to think about the grain and granularity. Those are two terminology. Just remember it. What is the thing? Later, if you are designing any fact table, the BT or the business side, they can ask you to create a grain with the subject area or to create some granularity with the subject area. So what is grain and granularity? Just like grain is the business definition of a fact table row. So a single fact table row, what the thing is signifying over here for a particular table, that is called the grain. Okay, let me show you a thing over here. So over here, this is a fact table. Okay, so this many things, the top sales ID, bill number, date, item code, and store ID, those are several foreign key we can say over here. Quantity and amount are main measures. Over here, we can say the grain of the table is sales transaction per item in a bill. Okay. Similar kind of that. This is a fact table over here. So you can tell this the grain of the fact table means individual record is marks of a student in a particular subject in a particular exam. Okay. So this is called grain. What a particular row signifies over here. So if we have a group by clause on top of subject for a particular student, we are neglecting the subject actually. We are summing up the marks over here for Aryan Dev and putting it over here. So there is no subject column. So the line items will not be splitted based on physics, maths, and English. Okay, if we have this kind of data, if you can understand me, I'm just repeating once more time. We are eliminating subject column over here. So for Aryan Dev, there should be only one line items. There should be only one row. And for these three subjects, that can be summed up of the marks over here. And we can find only one row for Aryan Dev. That time, what should be the grain? That should be marks of a student in an exam. There should not be in a subject clause over here. Because for each subject, the line items are getting splitted. Okay. So this is the concept. If we just, putting more granularity over here or grains over here, if we are just incorporating more columns, the particular grain should be more granular. It should be more in detailing level. I'll be telling what is granular now. Hope grain concept is clear. If not, please tell me. Okay, I think it's fine. What is grain? Just like when you will be quite experienced while designing or developing databases or data marts over there, your BT can directly tell you, create the fact table, create the billing table. The billing granularity should be, or grain should be this. Okay. So sales transaction per month, per item, per outlet, this kind of total things they will be mentioned. So each of the in grain, whatever columns they are mentioning, we need to pull all those columns from the source system to create this kind of fact table. Okay. Just like over here, you can understand marks of a student in a subject in an exam. Okay, moving on to the next topic, granularity. Grain we have covered. What is granularity? Granularity is quite dependent on grain. Just like whatever I was telling you, if we just incorporate more subject areas or more columns in the fact table, the thing should be with more detailing in the data. Suppose in the previous exam, we are saying that if we just eliminating subject, then for Aryan there should be one row, for Neha there should be one row, for Gunjan there should be one row, because subject we are eliminating. So we are not segregating the data based on subject, rather we are summing up the data, or we are grouping up the data top of subject and passing the marks only. So for that time, the data should be less granular. Granular means how much atomic level we are picking up the data. Okay. So suppose if we just with the subject, we are just putting one more thing over here. Suppose the question marks, short question, long question, this kind of thing. In physics, then that can be again segregated. Okay. In physics, what I have received for the short question, what I have received for the broad question. So it should be again splitted up. So it should be more granular again. But based on the business requirement, we need to think about the business, what they require, and we need to develop in the same manner. Okay. Okay. So that's the granularity. Granularity refers to the level of the details of the data stored in fact tables in a data warehouse. High granularity refers to the data that is at the near of transaction level. So at the transaction level means at the source system, whatever level we are assuming the data, that should be granular. That should be most granular things over there. But if we are aggregating those data based on some subject areas, we are declaring means or average or summation, then data should be less granular. The fact table should be less granular. Okay. The last line you can tell, low granularity refers to the data that is summarized. Okay. And if we are just taking data from the transactional data, we are not eliminating or we are not grouping the thing, then it should be atomic level data. It is more granular in level. Okay. Hope that is understandable. Granularity. If there is any stuck point, please ask me. Okay. I assume that is fine. Moving to the next slide. SCD. Now I am just in dimension. Okay. Just a quick concept. We are segregating the tables in fact and dimension. Okay. So if we can remember for the dimension table, what is dimension table? The product table. So just think in a factory, we are planting some, in a plant, we have the product, but what product tables consists? Maybe product name, product brand, okay, product code, this kind of information. So now think about it. If a new product can be launched, then that table can be updated. If no new product can be launched, no launched by today, for today's transaction or maybe next day's transaction. So there should not be any update in this product dimension table. It's similar just like customer or employee table. Suppose we have employee table, it's a dimension table. So in each of I just want to say in each of the dimension table, the dimension will not change very rapidly. Suppose we have employee table, it seems that nobody joins our company or nobody resigns our company regularly. So the particular tables data is kind of static in nature, or rather we can say it can be changed very slowly. So the dimensions are changing very slowly because those are the master data. But, but the fact table, the transactional data, those are changing very rapidly. So the transaction at the outlet side, okay, whatever debit, credit, or purchasing information, everything is being stored in transaction level, and those are especially the fact data. So fact records, fact table can be updated maybe daily basis, maybe hourly basis, because the transactions are happening within a second, within a minute. Okay. So facts are refreshed or facts table are changing just hourly basis, or it's a minutes basis, just like this. But dimension data, it's kind of fixed in nature, or it's changing very slowly. That's why we are storing the dimension data in three kinds of thing. One is SCD type 1, that is slowly changing database. SCD means slowly changing database. We can keep maintaining the dimension in either three of these cases. One is SCD type 1, another one is SCD type 2, another one is SCD type 3. I have an Excel file to show you quickly the difference between each of them. And this is an important question. What is SCD type 1? What is SCD type 2? And what is SCD type 3? From the interview side. So if you are just going to face an interview with an advanced level, they will be asking this kind of questions. Okay. Let me open this sheet to show you. I think I have a better Excel. No, there is nothing. Okay. Okay. So suppose this is a table, employee table, and we are learning first SCD type 1. Okay. Let me maximize it, or let me border it. Okay. So we have employee table. We are maintaining SCD type 1 data. Okay. Over here, we have employee ID, employee name, and employee designation. Okay. For SCD type 1, we are not maintaining any, complex thing over here, but there's maybe some drawbacks. Suppose, okay, I have stored the result of yesterday's data. This is the data, whatever we have received from yesterday's data. Now today, some data has been modified. So when we are loading as per the SCD type 1 data, suppose we have the new employee, or suppose we have, the particular employee ID, his or her designation has been updated to developer. Okay, we are storing, just like we have updated this information. You can see one ABC trainee has been updated to developer. So the information of the employee is updated over here. Okay, the other informations are fine. And we can find also there is a new employee joined with the employee ID 5. His or her employee ID is trainee. So two things has been updated over here. One record has been updated. Whatever we have received the record in at yesterday's session. So it was the data at yesterday, and today I received two changes. One data got updated in the system, and one record has been inserted. This is the new joining in the company. Okay. But the thing is, this is a strategy to load the data as SCD type 1. Okay. We can find two drawbacks. Suppose the manager or the higher level authority want to check which is the particular date that the particular employee has joined, or What was the particular date the employee got transited from trainee to developer? Or maybe the question may arise that whether the employee ABC, he or she has joined the company as a trainee, or he or she has switched from another company to this company as a developer, because we are not storing any history information of this particular employee in SCD type 1. Okay, so while fetching the history, it's not a good approach for SCD type 1. Okay, so to eliminate this thing, we can introduce SCD type 2 strategy. Let me show you. Okay, this is SCD type 2. Over here, we can see employee ID, employee name, employee designation, and we are introducing a new column, particular date. Okay, so we are just trying to eliminate some of the questions, whatever we have added, what all the things has been added at SCD type 1. So we are introducing this date. So again, we can see for that particular employee, he or she has been updated to developer, but we are maintaining both of the lines. So date is useful over here, which can able to split up the records. Okay, so this is the last transition, 23rd Jan. That particular employee was in training. 24th Jan onwards, the particular designation of the employee has been updated to developer. But we are maintaining the history over here in this manner. Okay, so this is called SCD type 2. And the new one for information would be also be stored over here, but the date means the last or latest transition date has been mentioned over there in SCD type 2, so that we can check the history or historical information. Okay, now if we just go ahead with SCD type 3, there is another loading strategy. So over here you can see that we are maintaining both of the records over here at the history side. Over here, we are not increasing the records. We are introducing another columns over here, just like as per the example, we are introducing date as well as previous designation. Okay. So just like employee ID, employee name, particular designation, transition date. This is the transition date, and we are also maintaining previous designation. Okay. Over here, we are just mentioning in this way. We over here, just a difference is we are not increasing the row level over here. The row is being increased over here to maintain the historical information. But over here you can see the rows are not increased, rather the particular columns are increased. But we are maintaining the same kind of information. So what should be the previous designation as well as the transition date? So we are maintaining the history as well with some more information in a single row. So this is the representation of SCD type 3. Okay. So any doubt? When we will be developing the code, if we are creating the dimension, our BT, that is business technical, they will be telling us go ahead with either SCD type 2 or type 1 or type 3. They will be telling us what kind of data or what should be the loading strategy at the dimension side. Okay. We need to store it in the same manner. Hope that is understandable. I'm moving on to the next topic. If there is any stuck point, kindly ask me. Okay. Now our fact and dimensions are ready. So if those things are ready, we can create the data modeling. So this is called data modeling. So we have centralized fact table over here, and surrounding it, we have various dimensions. Okay, so this is called data modeling. We are joining between fact and dimension based on those foreign key, as I told. Suppose this is a fact table, you can see those are all the foreign keys available. Each of the key is responsible for each of the dimensions primary key. We have time dimension. For that, we have the primary key time key, and the same time key is present over here in the fact as well. Okay. Similar thing is there for store key, product key. So when we just have to fetch any information from any particular dimension, we need to join between fact and dimension and fetch all the data. Okay. So this is the concept. Moving on with the next topic. I mean, this is very much important for data modeling. First of all, a particular business, data architect, they are going to design the data modeling first. How should be the data modeling looks like? Based on that, they can identify the fact table and dimension tables columns. Okay, so this is the first approach, as we are going at with some top-down approach while doing the architecting part. So the architecture, they go ahead with the first data modeling part. So it's a very important thing how the data modeling should be looking like. So when the data models are confirmed, then they can go ahead with building the fact and dimensions. And while building the fact and dimensions, they need to check from which source system the columns need to be picked up. Okay. So based on each of the source system, they are picking up the thing and they are designing or developing the ETL tool. So this is the entire thing that the data engineers are following. Okay. So while creating this data modeling, there are two conventional way. One is star schema, another one is snowflake schema. This is also an important question. What is star schema and what is snowflake schema while doing the data modeling? I'm just not I'm just going to the pictorial diagram over here. So star schema means there should be only one fact table. The fact table is centralized in nature, and the dimension should be surrounding it. Okay. The dimension should be having direct relationship with fact table, just like previous example as well. So there should be centralized fact and surrounding dimensions. Okay. And it should be looking like a star. So it is called star schema. So there is no interdependent dimensions available over here. Okay. Now, what is snowflake schema? We can see here is an example. We have this fact table. We have the dimensions, but over here you can see product dimensions, we have brand dimensions. Brand dimensions, it's not directly joined with fact table. Rather, it's been splitted from product table itself. So to get the brand information and to join with fact table, we cannot directly join with brand. Rather, product and brand table can be joined. And then again, joining with fact table, we can fetch the information from brand ID, brand table. Similar thing for category. So this is called snowflake data modeling, where the dimension table cannot be directly interacting with the fact table. Rather, dimensions are interdependent on each other, and it's looking like in this way. So it's called snowflake schema. In present scenarios, in present complex business scenarios, when we are developing a lots of things, we need to follow this way, because this is very simple in nature. Star schema, if the project is very less, if we have very few number of dimensions and that have interdependent, no interdependent between each of the dimensions, and if the design or development part is very easy, we can follow this approach. But in ideal scenario, we have lots of dimensions. Actually, I'm working in an insurance company. uh, not insurance company, actually the IT portion of insurance, where there are lots of dimensions available over there. So to store those kind of dimensions, we are using Snowflake data modeling. Okay. Otherwise it will not be possible to accommodate all the information. Okay, so our data modeling part is over. I think we are quite clear how to create the data warehouse, fact and dimensions. Okay, and how that can be designed from the architect level. What should be the data modeling? How to create the foreign key and primary key for each of the dimensions. That is quite clear from the data modeling perspective. Now I'm moving ahead with the ETL tool. So if you can remember ETL tool, it's been used for loading data from source to target. So this is called a job as well. Okay, the job is running daily basis. So whatever transaction we have made today at the source system, that can be loaded. If we run the job will load the data from source system to our target system. Target means the data warehouse system, from where the business analytics, the data scientist can work on top of data and they can take easy decisions. Okay. So ETL means extract, transform, loading. It's extracting the data from the source system. It's transforming the data or cleansing the data as per the data availability or the business requirement from the business side and loading it at the target site. Target means the Snowflake. Okay. Now there are various strategies to load the data the target. Even there are various strategies to extract the information from the source system. Let me show you. Okay. So data extracting method, there are two different extract method. One is full refresh, another one is incremental data load. So if we are taking data, suppose we have 3 records for today's transaction. Okay. So if we run the ETL job will store the data of these 3 records at my target site. That is fine. Again, tomorrow we have 2 extra records. Let's say we have 5 records, total 5 records. That means we have 2 extra records in tomorrow's transaction. Okay. Now we have two methods to extract the data. Either we can extract full data again, all the 5 records, or we can go ahead with incremental data load. That means it is also called delta load. So we can take only the extra records, whatever records has been pushing over there as an extra thing, we can take only these two. Okay. So based on our design method or based on the data volume, if the table is having millions of records, we will not be going to extract all the information daily basis because our job will take much more time. Okay. So the data getting appended at the source side itself. So we have 10 billions today. We have 23 billion should be there tomorrow's data. So we'll not be going to load all the data again. Rather, we'll be checking what are the new records comes. Okay. So based on that, we'll be going ahead with incremental data load. We can picking up those incremental data and load the same at the target site. So based on this extract, either it should be full refresh, means full data can be taken from the source system and that can be pushed at the target, eliminating the existing record at the target site. Let me show you the data loading strategy. Yes. See, if you are just going ahead with the full load, then we need to truncate the target table every day. Okay. Just to repeat myself again, if we are just going ahead with the full refresh from the source side, that means we are taking full data every day. That means full record means every record, whatever receiving, whatever we are receiving as a new records, we will be not taking into consideration. Rather, daily basis in a particular time, our ETL job will be running and our ETL job will be taking full data extract from the source system. It will be truncating our target system. Target tables means it will be deleting all the records from the target and pushing the records back. So every day they will be truncating the data. Otherwise, the data getting appended or data getting duplicated at the target site because we are fetching all the records. Okay. And if we are just going ahead with incremental data load, that means only the delta load, whatever data has been coming up, then we should not be going ahead with the truncate load. Either way, we can just going ahead with the insert data. That means the new record can be inserted only, or we can go ahead with upsert or called, that is also called update insert. In short form, that can be called upsert. We can go ahead with upsert method. Means In the source system, suppose we have any records that is getting updated. Okay, that is getting updated. In slowly changing dimension, you can also see that some of the employees designation has been updated in the source system, and some of the employee has been joined as a new resource. Okay, so based on the delta record, we need to check whatever records has been coming at the source system, whatever new records are there. So based on that, we can either go ahead with inserting the record, or we can update the record or upsert the record. Update whatever has been updated from the source system, and if there is any new record, that should be inserted. This is the upsert strategy. Any doubt? This is very important concept for ETL. Okay. If there is any doubt, kindly ask me. Okay. I hope there is no doubt for data loading strategy. Okay. So while learning the ETL tool, there are lots of ETL tools that are available in the market. Just to let you know. So maybe when you are quite, you have a quite good experience with the ETLs, as well as some overview on the data engineers and all, then you can go ahead with this kind of. You can choose or pick any one of ETL tool. Those are different vendor working on this ETL. So Informatica, IBM, Ab Initio, SAP, or SAP Data, I can say Cognos, Microsoft. There is in Microsoft there is SQL Server, Oracle, SAS. Each of the vendor is having its own tool. Now company has to choose which tool to pick up based on their licensing card, based on their performance, based on their throughput. Throughput means how many rows they can transfer per second. Okay. Based on the performance of the tool as well as the cost related to it for the business version, they can choose any one of the ETL tool while doing the ETL operation. Okay. You, you can take any of the ETL tool as per, based on your expertise, or based on your experience. You can take any one and you can go ahead with your experience. You can build up your experience over there on top of any tool. Nowadays, most of the business, not most, many more business users, they are not taking any tools over there. Rather, they're taking some languages, just like Python, Java. This kind of languages they're taking up, and they're creating some framework on top of this language. Okay. And that framework is being used as a ETL tool. They are storing the data from source system to the target. Okay. So those are open source. So there will be, no costing related to it, and that can be very much helpful. Okay. So that's why, in tomorrow's session, we'll be covering Python. Python I can cover the Python. I can start the Python from the basics from 2 or 3 days. After that, we'll be learning how to solve data engineering related things on top of Python. And after that, we can use Python as a ETL tool to store or to load the data from source system to target. And in middle, we can go ahead with some transformation. Okay. So that's why just ETL purpose, we have lots of tool available in the market, as well as some of the, business users, they are not using any tools, this kind of tools over there. They are using open source languages like Python, Java, and they're creating some framework. When the framework is ready, they're using the framework as a ETL tool to load data from source system to target. Okay, so we'll be using Python while learning the Python classes. We can, on top of Python or with the help of Python, you can load data from source to target. It will be working as a ETL tool over there. Okay, so moving to the next slide. Okay, so what is KPI? KPI is called Key Performance Indicator. So KPI it's been used as a dashboard site. So now think about our data modeling is ready, our dimension and fact is ready. That means our data model are ready. So data warehouse and data marts are ready. Now visualization team can work or data analytics team can work on top of our data marts data. They can build several charts and graphs. On top of that, business user or DSS, the decision maker can take their decision. What should be the next strategy at the source side? So that can be determined at the target. So here KPI plays the role. I mean KPI help or KPI can help us what kind of charts and graphs to be prepared on top of this data. Okay. So it can be helping us to visualize the data itself with graphical or graphical in nature. That should be graph or chart. Okay, let me show you. I mean, those are the example of KPI. What should be the sales growth? Sales growth is a KPI. Quarterly revenue. This is a KPI. Okay, so our business owner or business technical lead, they can tell us what are the KPI needs to put in the visualization dashboard. Okay, so the same thing can be developed by the visualization engineer on top of the data mart. When our data is ready, on top of that, they can build the KPI. Okay, KPI should be provided by the business itself, but we just need to develop the thing on top of dashboard. Okay, so this kind of dashboard we can see if we are just building the charts and graphs on top of data mart. Okay, just like there is a simple example. So zone wise, we are just giving showing the revenue, and there are times available as well. So in x-axis, you can find there are two dimensions. One is time, another one is zone. And in y-axis, we have the fact data that is called revenue. So two dimensions versus one fact informations are there, but that can be easily represented by this graph. This is a bar plot, and we can easily determine in a particular year what particular zone has the what revenue is achieved by what particular zone. Okay. Moving ahead to the next topic. So there is some more examples on the top of charts and graphs on top of basic visualization engineer. So this is called pivot table. We can transpose the thing. Okay, you can see the thing has been transposed over here. I'm just going to give you some overview of the visualization engineer. Here is a bar plot. How the bar plot can be shown on top of data mart data only. So when our data mart is ready, this kind of charts and graphs should be prepared for the end user, that is the decision maker. They can check this kind of charts and graphs and reports, and they can take the decisions. Okay, so this is another kind of charts and graphs. So it's a 3D plot of bar. Okay, here also we are preparing two different dimensions. In x-axis, this is the city. In y-axis, this is the year, and in z-axis we are using the measures or fact. In this particular charts, we can go ahead with slice and dice. What is slice? Over here, if we just filter out only, we can filter on top of a particular year. You can see only one dimension is present for this year, that is cities informations for different cells. So we are slicing the data over here. Okay, we are choosing a particular dimensions, that is a particular year, and we can check the data. This is as we are slicing the data. Here we are dicing it. We are choosing two different year, as well as we have also putting some filter on top of some city. We are not printing all the cities of information over here. Rather, we are checking only Mumbai, Delhi, and Kolkata. Okay. So that's why over here we can see it's dicing in nature. So slicing means we are choosing only one dimensions value. Dicing means we are choosing two data value, two different dimensions value. Okay. So there is another approach, what is called roll up and drill down. Over here, just like in this charts or in this bar, you can see if we are just double click on top of that city, I mean year or city. I'm just clicking double click on that particular year, 2013. Then the year has been splitted into several quarters. Now I'm double clicking on this 2020, 13 quarter 3. It's splitting up again with the months July, August, September. The same thing is there as well as over here as well. This is called roll up and drill down features. Especially we are drilling it down with more granular level. Okay, but this is not easy to develop. For that, we have to create hierarchical dimension. So we need to create in the time dimension table, we need to create year, then quarter and city such a way that when we have to set a proper relationship, and when clicking up, now it's as per the dashboard tool as well. Whatever visualization tool I'm using, if I am choosing the hierarchical dimensions over there, if it's properly worked, then that is possible in nature. So if you are just double clicking on 2013, it can be drilling down in this manner. And if you are just double click over here, then it's drilling down with month with lower granular level. Okay. So it's based on the tool we are using as well as the dimensions we have properly declared. This is called drill down. So if some days your BT or business technical is telling you to show the thing in drill down in nature, then you need to follow this way. And what is roll up? Just like the reverse, the vice versa. So you have the most granular at the first level and you are going ahead with upper level. So this is roll up. Roll up and drill down, those are two features as per the visualization engineer. So just like the same, you can tell the things over here and cover the things over here. So this is the aspects, some of the aspects I have mentioned over here as per the visualization engineer as well, how the charts and graphs should be looking like, and based on which KPI we need to choose which kind of charts and graphs. That is one of the important aspect, but you need to have some experience on top of that. Okay, so that's all for today's session. We have covered up what is ETL, what is data modeling, what are the things the data visualization engineers can work on top of the data mart and all. Now, if you are expertise in one of the subject areas, maybe you are good at ETL developer, you can choose your career on this thing. If you are good as the visualization type, you are good on top of data analytics part, you can choose as your career as a visualization engineer. There you can choose what kind of charts and graphs need to be prepared as per the KPI provided by the business user, and you can do the same thing at your own. Okay. Okay. The more thing will be providing tomorrow session. We are already been 5 minutes late over there. So let's connect tomorrow. We'll be starting Python tomorrow as well as some more insight I'll be just covering on top of business intelligence as well. Okay. So that's all for today's session. Let's connect tomorrow. If there is any stuck point, kindly ask me tomorrow
Excuse
as
me.
well. Yeah. Tell me.
Excuse me. So the link you shared to download MySQL, so is it for MySQL or the SQL Server?
No, it's only
Because
MySQL.
I have downloaded yes, MySQL, and one of my friends, she has downloaded like SQL Server, and she got many tables and all that data in this. So
No,
is there any
SQL Server
difference
and
with this?
MySQL, those are two different tools. So SQL Server, it's a Microsoft
Okay.
tools. Okay. You can see MS SQL Server, Microsoft
Okay.
SQL Server. That is another tool. So we have lots of databases available in the
Okay.
market. So we can choose any one. So over here in our demonstration, we have chosen MySQL. So anyone you can pick up. The coding languages or functional
Okay.
things are same. It's almost same, but some
Okay.
syntactical difference should be there when you are going ahead with SQL Server rather MySQL. Okay. Am I
So
understandable
can
or
we
if you are
get
asking?
existing tables
Yeah.
in? So can we get existing tables in MySQL?
No, MySQL actually it's as per the database. They are providing if you are installing a new software, they can provide some demo table over there. For your analysis purpose, they can already put some table inside the database. Okay. But in MySQL, even in MySQL as well, when we have installed the MySQL, whatever link I have provided, it's a MySQL link. Let me just show you. MySQL. MySQL download. Let me put. Okay, it's there. Let me stop the recording.